when participating in the challenge, there's a starting kit under the Participate tab, under Files on the left, to help you get started. We're also going to download some practice data to see how to use Docker with it and then submit it to the platform. When they finish downloading, go ahead and move them to a place where you want to work and extract the starting kit. Once in the starting kit, there's a README, and we can use that to go ahead and proceed. Next, with the terminal up, you can CD into the starting kit if you're not already there. And from there, there is code to unzip the PyTorch and the TensorFlow example. You should see 2 new folders of unzipped content, and we're going to dive into those. With each of those unzipped, we can now build the Dockers and show you how to create example submission Docker containers that you can use. So if I set an environment variable name for a PyTorch-based Docker and CD into the PyTorch example folder, I can go ahead and build a PyTorch container. I can do the same for TensorFlow. So I can store the TensorFlow-based name for the Docker name tag, and then go into the TensorFlow code folder and build that image. We're going to practice evaluating on 10 DICOMs using the PyTorch Docker image. So if we store that image that we built into the Docker name variable, we can use it later. Down here you'll see a link to the website, which has the starting kit and the practice data. You can go ahead and click that for a direct download. Or this link is tied to the button and can be used on headless machines if you want to use wget on a server. So proceeding, I've already downloaded that data. We can extract it here and look inside and see the 10 DICOMs and see a structure of the file. So we have a key file name path column and a class. So here is just an example of 2 of the rows in that file. So the next part of the instructions say to unzip this data, which we've done, and place in starting kit participant submission directory in. This is practice for what your algorithm is going to see when it's running on the platform. So if we open this, we can see in and out. Source data will be located at input, and your output classifications need to go into the output folder. So we can go ahead and copy these DICOMs in to the input folder. Now we're ready to run inference on them. So setting up a couple environment variables to run inference, we can run the Docker image that we already set up. Notice here that we have the flags IT for interactive terminal mode, and you can use bash as your command for debugging. This will delete any intermediate containers to make sure you're not cluttering your machine when you're done using it. This establishes that the network for Docker is the same as the host machine. And here are the most important flags. Basically, we will be mounting the path /mnt/in and /mnt/out to the location of the data. So to simulate that, here in our present working directory, we have the participant submission directory, which is right here. And then we have an in with all the images and an out where the classifications go. So when you go looking for your data, look for it in mnt_in and put the output of your algorithm in mnt_out, and we will handle the rest. Finally, for this implementation, we set the working directory to app, and using the Docker image that we previously specified, which is PyTorch, we can go ahead and run this example. Now what this will do is make a classifications file for each image and output the confidence and probability that this image has COVID. That's all you need to do. If your algorithm can generate a file that looks like this, then it should be able to be graded by our program. Now that we have our classification output, we can go ahead and zip up our algorithm for submission on the system. So make sure that you include in your output your classification results and your model. And so we will take care of naming your Docker image for our own uses. So don't worry about that too much. Essentially what you need to do is for the PyTorch or the TensorFlow implementation, you can zip up your Docker file, which should go ahead and construct everything about your Docker image necessary. And these are the same for PyTorch and TensorFlow. And any code you need, so here inference.py, your model, and any requirements you may need to install when your Docker image is built. Just to give you a small summary of what this file does, like we discussed, in /n, /mnt_in and /mnt out, we have our in and output directories. Here, for example, with PyTorch, we can test if the GPU is available or not and use it if so. Here, we gather the images in the in directory to generate a key for our CSV file output. Finally, your algorithm will need to create the classifications for each image, but we can simulate this by just generating random answers between 0 and 1. Finally, we write the output to the output directory, and we also copy our model. That's everything you need to do in order to get it to run properly on the machine. The last thing I'll say is that if you notice the way that this directory is structured, all the data and files are at the first level, especially the Docker file. It doesn't necessarily matter how you construct this, as long as your Docker file is at the root directory and can access all data it needs to build the image correctly. Sometimes when you zip up an image, the folder that's being zipped or the data shows up inside the zip archive. This is going to cause an error. We really need the zip archive at the root level to have the Docker file and associated files relative to the Docker file. Let me show you an example of what I mean. So if we zip up the PyTorch image into a new archive, we can see it here. And if we open it, you can see at the root level is the Docker file, which references these files inside, namely requirements.txt, inference and model here. It can see those from where it is. All your data needs to be such that the Docker file can build it from the root directory for there to be no errors.